Hi class. For this lesson we're going to be talking about independent and dependent events and the probability of those things happening. For starters, let's look at probability of independent events. When we look at the probability of independent events, what we're saying is that, say we have a couple of events that happen in a row, the first event doesn't necessarily affect the second event, and the second event doesn't affect the third event. So what we're doing is we're never removing possibility from the body of options. One way that we can look at this is if we're looking at a number wheel. Okay, so let's say that we're interested in the possibility of 2 spins. So we've got 2 spins, and we want to know the possibility of landing on either a red or a red in 2 in a row. Well, the first spin that I'm going to spin the spinner in a spinny way, I have 2 different options and I have a grand total of 8. So for my first spin, landing on a red is going to be 2 out of 4. For the second spin, I already spun it once, but that doesn't mean that I removed any colors at all. So that means that if I'm trying to land on a red again, well, that's going to be the same. It's going to be 2 out of 4. And then from there I'm just going to multiply straight across, and I end up with 4 over 16, which reduces nicely down to 1/4, or 25%. Another example we could look at is, say we want to spin first a red, then we want to spin a green, and then we want to spin a red again. So what's the probability that we'll spin red, green, red? Okay, for first of all, we already figured out the probability of figuring out a red. That's going to be 2 in 8. Okay, and then spinning a green, well, that's going to be 3 in 8. And then again, spinning a red is going to be 2 in 8. And remember, each time I do one of these spins, I'm not adversely affecting the probability of the next round. So from here, we're just going to multiply straight out. So 2 times 3, 6 times 2 is 12. All over 8 times 8 is 64 times 8 is 512. And if I checked it right, I'm pretty sure 12 is divisible into here, and what I end up with is 3 over 128. And from there, if we were to do some fancy footwork, we could probably come up with a formula, or I'm sorry, not a formula, we could probably come up with a percentage, and that percentage is 2.3%. When talking about the probability of dependent events, what we're looking at is when 2 different events or multiple events occur, and every event that happens after the first one affects all the others. It's kind of a domino effect where one affects the other. Well, let's do an example to see if we can make some sense out of this. So say we have a paper bag, and inside this paper bag we have 2 lemons. Okay, so we've got 2 lemons. And we also have 1 lime. And that gives me a total of 3 fruits. I hope we can all agree on that. 3 fruits in the bag. Okay, what we're going to look at first of all is the probability, so event number 1. And that's the probability of pulling out a lemon versus the probability of pulling out a lime. And then after that, event 2 is we're going to look at what is the second thing that we pull out of the bag. So in the first case, when I reach in the bag and I pull out something, the number on top here is the number or likelihood that, or the number I want of that event to happen, and the number on the bottom, well, that's the total different possibilities. So say what I'm looking for is I want to pull out 2 lemons. First grab, my event, the likelihood is going to be 2 out of 3. Because there's 2 lemons in the bag, 3 total, I'll pull out 2 of the 3. Okay, so that's the first event. Now the second event, since I have 1 lime and 1 lemon left in the bag, that event is going to be 1 out of 2. So event number 2 is 1 out of 2. When I'm working with dependent events, since the first event affects the second event, notice how the denominator is now 1 fruit less because I pulled 1 out of the bag. Okay, so from here all I have to do is the math, and I'll do 2 divided by 3 times 1/2 And the likelihood of pulling out 2 lemons is 2 over 6, which can be reduced down to 1/3 and equals, what is that, 33%? Okay. Let's look at the case if I was to pull out 1 lime first and then 1 lemon. So event number 1 is the case that I'll pull out 1 lime. Well, that's going to be 1 in 3, because in the 3 fruits there's only 1 lime. The case after that is, well, what's the case that I'm going to pull out a lemon left over? Well, since I already pulled out the 1 lime that was in the bag, all that I have there is a lemon. Okay, so that's going to be 1 out of 1. When I multiply those two together, I get 1/3. Again, 33%. Okay, one last example. Same teacher, different room. In this table, we're going to look at domestic migration within the U.S. from 1995 to 2000. And we need to look at the probability that a person is randomly selected from specific groups. Here's our question set right here. So first off, for problem A, let's look into the probability that an immigrant is from the West. Now remember, when we're doing probability, we're always going to be doing, get a straighter line here, we're always going to be doing the total number of events, so this is total, divided by, in the numerator is the number of events we want. Okay, in this case, when we're looking for the probability that an immigrant is from the West, well, the thing that we want is the immigrant from the West, so E from West. And then what we're interested in for the total body is all immigrants. Okay, so if I was to do a little bit of math here, what I would do is I would add up all the immigrants in this body right here, and that ends up being, this is how good I am at math, 1,656. That ends up being 11,656. And then for my numerator, since I'm looking for just immigrants from the West, well, I'm just going to pull out that number from the West being 2,654. 2,654. Okay? And if I was to pull out my calculator and figure out the percentage, that percentage ends up being about 22.8%. Okay? So there's the first part. Let's go ahead and check out part B. All right, so on part B is asking the probability that someone is selected from the South region is an immigrant. Okay, so what that means is we're going to be looking at just the South region. So the number of events total is just right in here. Okay, that's the total possible events. So in my denominator, give myself a nice bar here, in my denominator, the number that goes down here is 8,285. Okay, and then in the numerator, what I'm looking for is the probability that someone selected from the South region is an immigrant. So I'm specifically interested in that number right there, which ends up being 5,042. When I plug it into my calculator, I end up with a percentage that's about 61%. Okay, for part C, we want to know the probability that someone selected is an immigrant and is from the Midwest. Okay, so let's think about this for just a second. If we want to set up the denominator in our probability fraction here, if we're looking for someone that is an immigrant and a Midwest, that means that we're probably interested in this entire population here. We want to know the full number of that. So when I add up all of those numbers together of immigrants and of immigrants, I get 23,311. Whoop, one extra number. Okay, 23,311. And then what I'm specifically interested in is the probability that one of these people is an immigrant in this direction and also someone that is from the Midwest. Okay, so I'm not looking at all immigrants, nor am I looking for all people from the Midwest. I'm only looking at someone that is from the Midwest and that is an immigrant. And in the end, that number is 2,951. And when I punch that into my calculator, the percentage that I get is 12.7%.